Okay, and let me know when you're ready to go over the warm-up. We can go ahead and start. Okay, so I'm going to switch screens so that you guys can see both the warm-up and the document camera. And I'm also going to open the document camera. Ah, don't do that. It gets mad if you line it up too perfectly. All right, there we go. Ignore the picture above your warm-up thing. You see, Brandy's messaging me. She has to restart her computer. Nothing's working. Ah. Oh. Okay, so I asked you guys to find the domain and range of the function shown in the graph. Okay, so we'll start with domain and then do range. Since there's only 3 of you, if one of you would just volunteer.
I got domain.
All right. You said -5 to what?
8.
Oh, why did I do that? Apologize. And what type of brackets am I going to use?
Is that open or closed? I can't see.
Hold on. Let me just zoom this in for you.
You're gonna put parentheses next to the 5 and a square bracket next to the 8.
Beautiful, perfect. All right, and then either Tanaya or Francesca, if you'll do the range.
Is -4 and -3.
So -4 is here, right? And -3 is here. That will mean that the lowest that the
I meant -2.
So -2 is here. Okay, that would. Are you thinking that that's where the lowest that the function goes or the highest?
Oh, so it would be -2.
Negative what?
Oh.
So what's the lowest that the function goes?
Wouldn't it be -9?
Yeah, -9. And is it going to be open or closed?
Open.
And then the highest that the function goes is up here, right? So Tanaya, what's this one gonna be? I think you had it earlier.
-2.
Yeah, and is that gonna be a square or a round bracket? So it's not, it doesn't have an open circle, right?
Oh, it's gonna be a bracket.
Yeah, so it's like a square bracket. Good job. Okay, so remember domain is left to right. Range goes down from the lowest point to up, so or lowest to highest. Okay, so we start low, then go high for range. Okay, questions on that warm up before we take notes for today? Okay, if there are no questions, we'll go ahead and take notes. So I'm gonna flip this page. Oh, so much. Okay. Let me grab my pen that fell. All right, so today we are going to talk about, let me get rid of this warm up and also make this thick. Okay, so today we're going to talk about solving absolute value equations. Okay, this was kind of challenging for the last honors class to do. Hopefully you guys will catch on a little bit more quickly. So these notes are on solving absolute value equations. And the document that is on Canvas right now are the notes that I gave the Honors 2B class. So you can look at those if you feel like you are not keeping up. But you feel free. We're just writing notes on notebook paper. Yay. Welcome, Brandy.
Hi.
I am recording, so the warm-up will be on the recording when you pull it up. So we're jumping into notes right now, and that's all we've done, okay?
Okay, thank you.
Yeah, you're welcome. Okay, so we're taking notes on solving absolute value equations. So absolute value equations have to have the absolute value in them, and they're going to have an equal sign in them, right? So they're going to look like something like the absolute value of x is equal to a. And this means, so the absolute value, it really just represents a distance. So a could represent a positive value. So maybe the absolute value of x is positive a. It also could give you the negative value. Okay. Actually, I don't like the way I wrote this. I'm going to take the absolute value marks away from this because the absolute value of a value cannot be negative. Okay, so there are two different ways we can write the absolute value, one with a positive and one with a negative. The A is in the set of real numbers, which just means that it is a real number. Okay, it's in that set. So A is in the set.
Excuse me, Miss Roberts.
Yes.
I'm sorry, I'm feeling a little sick. Can I turn off my camera right quick?
Of course, yeah. Okay, so this little symbol here, the E, it's an epsilon. It just means in. This double bar R means the set of real numbers. Real numbers are positive and negative and zero values that are not necessarily integers. They're just not complex numbers, so nothing with an I in it. And there can be decimals, they can be fractions. So that's all that means. You just put a number in there. Okay, and the absolute value of x I said this earlier, but we haven't written it, represents the distance from x to 0. Okay, that's why we'll always end up with a positive value when we have the absolute value of something. Okay, his distance is always positive. Okay, and I'll draw an example of this. So if I had the absolute value of 4, it's just asking how far 4 is from 0. Similarly, if I have the absolute value of -4, it's asking how far -4 is from 0. -4 is still 4 units from 0. So if I drew this out on a number line, I'd have 0, -4, +4, and these distances here are still the same. So D equals 4, where D is distance. Okay, what questions do you guys have so far? I've kind of sped through this. And Erin, if you need to like leave and then just watch the recording, that's okay. Okay, so any questions on what we've talked about so far? The absolute value is a distance. Okay, so an absolute value, and I said this earlier, value equation. I've got way too many loops in this. So an absolute value equation will have several components. It has to have these absolute value bars, okay, and an equal sign. Okay, so these are absolute value bars. Okay, we'll do a bunch of examples. So in our first example, we're going to have the absolute value of x plus 3 is equal to 7. Okay, now just like at the very top of our notes, we're going to split it up into its two possibilities.